Now, let's solve a question from the IB Questionbank. In this question, give all your answers to 2 decimal places. Brian decides to purchase a new car with a price of 14,000, but cannot afford the full amount. The car dealership offers 2 options. The first option, A, there's a 6-year loan at a nominal rate of 14%, the interest compounded quarterly, no deposit is required, and repayments are made each quarter. For part AI, we need to find the repayment made in each quarter. First, we have to find for part AI, N, which is the number of payments. This is equal. I have 6 years and paying quarterly. So each year I'm paying 4 times. So the number of payments is simply equal to 6 times 4, which is equal to 24. And then the interest rate is equal to 14. And the present value is equal, since it's a loan, Brian owns them negative 14,000. Since owns, then his account is negative. Now, the payment amount, we don't know. We need to find the payment amount. The future value is simply equal to 0 because he wants to pay the loan. The payments per year, he may pay 4 payments per year. And the compounding per year, there are 4 compounding periods per year. We use our graphical display calculator now. We exit. We go to menu, to the financial. And in the financial, we go to compound interest, F2. Now, the number of payments is 24. The interest amount is 14. The present value is negative 14,000. And the payment, we don't know the payment amount, so we keep it. The future value is 0. Payments per year is 4. And the compounding per year is also 4. We go now to PMT. And we find that the payments must be 871.82. So the payment is 871.82 euros. So for part AI, each payment he has to make is 871.82. For part double I, we need the total amount paid for the car. For the total amount paid for the car, we need to use the same process. Already we have that the number of payments is 24, right? So total amount is simply equal to the number of payments, which is 24, times 1 payment, which is 871.82. And this is equal to, we go to the run matrix. We have 24 times 871.82, 871.82. So the total paid amount is 20,923.68. 20,923.68 euros. This is the total amount that Brian has to pay for the bank. Part A, triple I, we need to find the interest paid on the loan. We said that simply the future value is equal to the present value plus the interest. So I have the PV to be 14,000 equal to the future that he will be paying is 20 to 3.68 plus the interest rate paid. So now the interest rate is simply equal to this value minus 14,000. So this answer minus the 14,000, and this is equal to 6,923.68. So this is the interest amount paid. Let's go to part B of the question now. A 6-year loan at a nominal interest rate R, compounded monthly. Terms of loan requires a 10% deposit and monthly repayments of 250 euros. It means he must deposit 10% of the loan amount, and he has to pay monthly payments of 250. Part BI, we need to find the amount borrowed. So now he deposits 10%. So the deposited amount is equal to 10%, which is 10 over 100, times the total value. So he must deposit 1,400 euros. So by this, the borrowed amount is equal to 14,000 minus the 1,400, and this will give us, it's 14,000 minus the 1,400, and this gives us 12,600 euros. So this is the borrowed amount. Part B double I, we need to find the annual interest rate R. Also, we have the number of payments to be equal. N is equal, have 6 years and monthly payments, so it's 6 times 12. So the number of payments is equal to 6 times 12 is equal to 72 payments. We have the present, we have before the present value, the interest rate. The interest rate is unknown. We have to find the interest rate. The present value is simply equal to negative 12,600. Because it's a loan, he'll be taking the 12,600 euros. And the payment amount is, we know the payment amount is 250. And the future value must be equal to 0. And we have the payments per year equal to 12, since they are monthly payments, and the compounding per year is also equal to 12 because it's compounded monthly. So now to find the interest value, I go to my graphical display calculator, I go to the financial, and we go to compound interest. I have N to be 72. The interest rate, I don't know it, I leave it for now. And the present value is negative 12,600. The payment amount is $250. The future value is 0. The payments per year is 12. And the compounding per year is also 12. And the unknown is the interest rate. So simply I press F2, which represents the interest. So the interest rate is equal to 12.56%. So I is equal to 12.56%. This is the annual interest rate. Part C of the question. State which option Brian should choose. Justify your answer. If we want to justify our answer for which choice is better for Brian, we can see that the first loan is on a higher interest rate, and he will be paying a bigger amount as an interest, while the second loan is on a lower interest rate, but he has to pay a deposit amount. So Brian depends on what he has. In the first part of the question, it said that he cannot afford the full amount, but he can pay a deposit amount. So it's better for Brian to choose option B, because he will be paying a lower interest amount. Let's go to part D now. Brian's car depreciates at an annual rate of 25% per year. Find the value of Brian's car 6 years after it is purchased. So for part D, we have the future value to be equal to the present value, which is 14,000, times 1 minus, because it depreciates, 25 over 100, all of it to the power of the number of years, which is 6. So now the future value is simply equal to, I use my graphical display calculator, I go to run matrix, and it's 14,000 times 1 minus the 25 over 100, all of it to the power of 6. And this is equal to 2,491.70. So it's 2,491.70 euros. If you can see, all answers are written to 2 decimal places because the question asked for so, and we used the financial applications in order to find monthly payments, quarterly payments, an unknown interest rate, and we find the depreciated value of the car after 6 years using the future value formula.